Welcome to 4.8, division polynomials. This is not the last section. There's an appendix that we use after this for synthetic division. But knowing polynomial long division, you don't have to actually know the synthetic division. It's just a shortcut that works in some cases, but not all cases. So how we divide polynomials is based on what the polynomial in the denominator is. That is the divisor. If we're dividing by a monomial, we just use this principle, which is the same as when we're adding fractions, essentially. So if we look at this in the first context, notice, here we're dividing by a monomial. We have x minus 2x squared minus x to the fifth all divided by x. So we can split the numerator up over that denominator. We can say this is going to be x over x minus 2x squared over x minus x to the fifth over x. And then individually we divide these just using that rule of exponents. Now if you recall, if we have a to the m over a to the n, this is always a to the m minus n. That is, we subtract the power of the denominator off the numerator, or we can think about it in terms of cancellation. So right here, when we're doing this right here, we split this up into all monomials. Or because we had a monomial in the denominator, we can split this up. Now x divided by x is just 1 minus. This takes care of one of these x's, so this is minus 2x. And then here, if we have x to the fifth divided by x, well, one of this x here takes care of one of those, leaving us with x to the fourth. So this is what we're looking for right there. Now, same thing here. We're dividing by a monomial again. The monomial is 4x cubed. So we can write each of the terms in the numerator over that denominator piece. So we can write this as, let me do this, 24x to the fifth all over 4x cubed. I'm going to make that more like a 4. Okay, minus 40x to the fourth all over 4x cubed. Then plus 6x cubed over 4x cubed. Now, we do what we normally would think we do. We divide the numbers by the numbers, and the variables, we take care of those. So 24 divided by 4 is 6. So this is a 6. Now, x to the fifth divided by x cubed is going to be x squared. We subtract the 3 off of the 5, or we can think of 3 of these, take care of 3 of those, leaving us just with an x squared. Here, 40 divided by 4 is 10, and then x to the fourth divided by x to the third, 3 of these, take care of 3 of those, leaving me with just an x to the first. And then finally here, if we divide 6 by 4, we could use decimals, we could use 1.5, we could reduce it to 3 halves. I'm good with either of those. Let's just say 3 halves. And x cubed divided by x cubed is 1, so that is what we have right here. Okay. Now the last one we're going to do is we're going to divide by a monomial where essentially it has multiple variables. It's not that big of a deal. We just consider the variables individually and kind of proceed like we had them before. And this is all dividing by a monomial, mind you. When we divide by a binomial or trinomial or larger polynomials, it changes. We're going to get to that in a second. So here, because we're dividing by a monomial, we can split this up. We can say we have 9r squared s squared plus 3r squared s minus 6rs squared. Now, this is over 3rs over 3rs over 3rs. So we're splitting up each of these terms in the numerator and dividing by its denominator. So we just do it piece by piece. 9 divided by 3 is 3. So right here, that's giving us our 3. R squared divided by r, this takes care of one of those, leaving us with an r. S takes care of one of those, leaving us with an s. Plus, 3 divided by 3 is 1, so that's a 1 right there, they cancel. R squared divided by r, this takes care of one of those, leaving us with an r. And then s divided by s, they cancel out as well, leaving us with a 1. We're good. Then finally, 6 divided by 3 is 2. R divided by r is 1, they cancel out. And s squared divided by s, this takes care of one of those, leaving me with an s. So we have 3rs plus r minus 2s. And that's that right here. Okay, So divided by a monomial, pretty straightforward. When we divide by a larger polynomial, it gets a little bit different. Now, recall when we used to have to do things like this, and we're dividing using polynomial, or we're using long division here. You know, we go 23. You know, let me erase that. That's starting to get crazy. So 23 goes into 1, 2, 3, 4, 5. Let's just do that. We don't really need to do much more than that. So I think, how many times does 23 go into 12? Or 1, it doesn't. But how many times does 23 go into 123? Probably 5. So the first thing we're always doing is we're saying, how many times does this go into this? So we're dividing. So the first step is always divide. After we divide, we put our 5 up here, and then we multiply. So we say 5 times 3, 15, carry the 1. 5 times 2 is 10. So 115. So second thing we do is multiply. Okay. After we multiply, we always subtract. So subtracting this off, we got to borrow from there, making that a 13. So it's going to be 8. So third thing we do is subtract. And then the final thing we do in generally this situation is we bring down the 4. That is, it's 4 comes down. So 4 bring down. And then it starts all over. And we do the divide, the multiply, the subtract, the bring down. So let's just kind of go through another repetition of this. Now, we say 23 goes into 84. Let's go 6 times. So we put our 6 up here. 6 times 23. Well, 6 times 3 is 18. Carry 1, 6 times, whoa, definitely not 6 times, 3 times there, sorry about that. So, how many times does 23 go into 84? Let's go with 3. So 3 times 3 is 9, and then 3 times 2 is 6. So we subtract this off. So we borrow that, make that a 7, that's a 1. 19, that's a 5, that's 1, 150, and then so we bring down. So once again we divided, we multiplied, we subtract, then we bring down. Now we brought down our 5, so essentially we're done with that right there. Now I think, how many times does 23 go into 155? Maybe 7? I'm not totally sure. Like, I think 7, let's do this really quickly. 7 times 23. Oh, that's not going to work. 6 times 23. So we got 6 here. So then we do our multiplication. 6 times 23, 138. We subtract. And we get 17. So what we can say is this, and really what I'm trying to get you at is try to get at is a couple things. First thing, there's a procedure to this long division. We're going to be doing this polynomials in a minute. And the procedure is divide, multiply, subtract, bring down. Now the other thing is this. If we have 1, 2, 3, 4, 5 divided by 23, how many times this goes in evenly is 536. The quotient is how many times this goes in evenly. So we have 536. The remainder is the piece that didn't get divided by this, the divisor, so we can say this is plus 17 over 23. So, this is the quotient. What's up here? The remainder is the piece that didn't get divided by the divisor. That ends up right there. Okay, and we have this procedure of divide, multiply, subtract, bring down. So let's just see how this works in polynomials. We're going to do this polynomial division right here. Now, x minus 2 is doing the dividing. And x squared plus 5x minus 9 is being divided. Okay, so if nothing else, we can set this up. We know that this is pretty much what it should look like. Now, the dividing part's going to be a little bit different. And recall, we're dividing, multiply, subtracting, bring down. First thing we do is we divide this by this. So if we have x squared divided by x, that is just going to give us x. So I divide. Now I put my x on top of my x to the first. We keep everything lined up because it's writing big and writing clear, and these is really important because it can get really bad really fast. So first thing we did is we divided. Now we multiply. Just like we multiplied up there, we multiply this by both of these terms here. So x times our x, that's our x squared. X times our negative 2, that's minus 2x. So I've multiplied this right here by both of these terms right here. Okay, so we divided, now we've multiplied. Now we subtract. Now when we subtract, we're subtracting this whole polynomial. So this negative carries through to here, it distributes over here, and turns this into addition. So we subtract x squared minus x squared, they cancel. 5x plus 2x is 7x. We've done our subtraction, so now it's time we bring down our negative 9. So I know this is a little bit weird and a little bit tricky, but that is one full cycle of this. Now, we brought down the 9, so we have one more cycle of this. And let me show you what we do. First thing we do, we divide. Now, what do we divide? We divide this first term here by this first term here. So 7x divided by x is 7. So we put plus 7 up here. Right? So that was our dividing. Now it's time to multiply. Now we multiply the 7 by both of these terms here. So 7 times x is 7x. 7 times negative 2 is negative 14. So we've multiplied. Now it's time to subtract. So subtract. So this is going to distribute in here, making that negative. Distributes in here, making this positive. 7x minus 7x cancels, they go away. And each time it should, like these x squareds went away, these 7x's went away. By design and construction, it's going to happen like that. Now, negative 9 plus 14 is 5. 5 is the remainder. So what we can say is that, and this is really what we're saying here, is that x squared plus 5x minus 9 divided by x minus 2. How many times does this go in evenly? Well, it goes in x plus 7 times evenly. That's the quotient. What's the remainder? Well, 5. The remainder is the piece that didn't get divided by the divisor. So it's 5 over x minus 2. And that is how we divide polynomials. So I'll see you in the second part for some more polynomial long division.